and I guess most of you have already covered the space technology, and only a few of you, okay, you have not covered the space technology. So how many of you have not covered the space part? Okay, I think half of you have not covered the space part. It's okay, we are doing it again. So the story of the Indian space exploration, it began in the 1962. Okay, the story of space exploration in India, it began in 1962. And please keep noting all of the information that I am giving you. So in the 1962, there was an Indian physicist by the name of Vikram Sarabhai. सभी ने नाम सुना है विक्रम साराभाई? Okay, so Vikram Sarabhai, he was an Indian physicist and he was interested in the space. Okay, so he was a physicist and obviously इन्होंने general theory of relativity ये इन्होंने obviously पढ़ी होगी because he was a physicist and he was interested in the deep space exploration, okay, as well as in the atomic energy. तो जो भी हमने black holes, galaxies ये सब हमने पढ़ा है, so इस person ने उन सब में इनकी detailed knowledge थी. Okay, so Vikram Sarabhai, he was an Indian physicist, and he was also awarded the Padma Vibhushan by the government of India. And in 1962, he established the, he's right, INCOSPAR. And INCOSPAR is, it is the Indian National Committee for Space Research. Indian National Committee for Space Research. Okay, सब लोग लिख पाए? INCOSPAR क्या है? Indian National Committee for Space Research. And this committee was part of the, there is one institute in India which is the TIFR, Tata Institute of Fundamental Research. So this TIFR, it is in Mumbai, and TIFR is involved in research in theoretical physics, mostly in theoretical physics and in the experimental physics. So this INCOSPAR, it was a part of TIFR. Okay, it is related to TIFR. In 1962, Vikram Sarabhai established the Indian National Committee for Space Research, and later this INCOSPAR, it will be superseded by ISRO, Indian Space Research Organization, in 1969. Okay, so INCOSPAR ही ISRO में convert होगी 1969 में. ठीक है, basically the functioning जो INCOSPAR, the Indian National Committee for the Space Science, was doing, the same functioning it will be done by the ISRO. And in 1963, first, you have any question?
No, sir.
Okay. So in 1963, there is a place Thumba. Thumba is in South India, in Thiruvananthapuram. Pardon me if my spelling is wrong. So Thumba is in Thiruvananthapuram, and the first launch vehicle, the first satellite launch vehicle, it was established at Thumba. Okay, so Thumba is in Tamil Nadu, and the first satellite launch vehicle. It was established at.
Tumba is in Kerala.
Yes, I guess Thiruvananthapuram is also in Kerala. Okay, Arya.
Yeah.
Mumbai is in Kerala, and because Thiruvananthapuram is in Kerala, so Mumbai is in Kerala. So it was the first launch pad, first launching facility. Okay, it was established in 1963 by the INCOSPAR, and here we launched the sounding rockets. It was a facility for launching the sounding rockets. किसी को कोई idea what are these sounding rockets? Do you have any idea what are these sounding rockets? Okay, so these sounding rockets, they are launched to study the atmosphere. The purpose of sounding rockets is to study the higher atmosphere, upper atmosphere. Okay. So these sounding rockets, they are basically for the studying purposes, and they collect data about the atmosphere. So by using the sounding rockets, we study the atmosphere, we gather data about the atmosphere. Okay, clear? Then ISRO was established in 1969, and it superseded the INCOSPAR. So Indian Space Research Organization, whose headquarter is in, where is the headquarter of ISRO? Yes, headquarter of ISRO is in Bangalore. So ISRO was established in 1969, and its headquarter is in Bangalore. And in the year 1972, the ISRO was brought under the Department of Space. We have the Department of Space, okay, under the Prime Minister's office. Under the Prime Minister's office, we have the Department of Space, and Department of Space, it controls the ISRO. Hierarchy clear hai? So Department of Space is controlling ISRO, and Department of Space is in the overall. There is no Ministry of Space. There is no Ministry of Space. We have the Department of Space, and it is directly under the PMO. We also have the Department of Atomic Energy. Department of Atomic Energy is also under the PMO. Okay. These departments, they are not under the Ministry of Science and Tech. Okay. So these are the separate departments under the direct control of the Prime Minister. Yes, basically, you can say that INCOSPAR is the parent organization of ISRO. Okay, so it was the idea to explore the space. It was the idea of Vikram Sarabhai, and later the government of India. Okay, they lent support for this idea. So finally, when the Indian government owned this idea, it became ISRO, and it was brought under the Department of Space. Okay. So this Department of Space, it is the nodal agency or the apex agency, means the highest agency. Department of Space is the highest agency regarding the space programs and policies. साथ साथ लिखते रहो, the Department of Space is the nodal agency, NODAL, or the apex agency for the space related research and policies. And Department of Space, it also provides the funding. Okay, the funding is provided by the Department of Space. कोई भी इंडिया का मिशन होगा, be it the Mangalyaan or be it the Chandrayaan, okay, for every project the funding will be provided by Department of Space. When the Chandrayaan 2, okay, it failed to land on the moon, then Prime Minister, he himself consulted the ISRO chief. Okay, so the Prime Minister office is actively engaged in the space research from the times of Pandit Nehru. The Indian Space Program, Indian Space Research Program, okay, this Indian Space Research Program, it is the vision of Dr. Vikram Sarabhai. सभी को clear है? Indian Space Research Program is the is the brainchild of Vikram Sarabhai, and there were some aims. There are some aims of the Indian Space Research Program, because this was the time after the Second World War. Okay, and the world witnessed the huge destruction during the Second World War. So this Vikram Sarabhai, he was a believer in non-violence. So he said that we will use the outer space for peaceful purposes and not to develop any kind of weapons. Okay, so the one aim of Indian Space Research Program was the use of outer space for peaceful purposes. Okay, so he was not in favor of developing the fighter jets or the technology, okay, the weapons of mass destruction. He was not in favor of producing those. So Indian Space Program, one of the aim was the outer space, it should be used for peaceful purposes. And the second aim was the establishment of space services pardon me. The second aim was establishment of space services like the indigenous launch vehicle system, okay, to send our own satellites. So he wanted to build the indigenous space services for launching the Indian satellites. Okay, space services which are indigenous. So this was the vision of Vikram Sarabhai. There are two aims: the development of the space services like the launch vehicle services, okay, to launch our own satellites, and to use the outer space for peaceful purposes and not for making the weapons of mass destruction. Clear? Very good. So there are many, okay, there are many wings under the ISRO. We have ISRO, which is headquartered in the Bangalore, and there are several arms, we can say several wings of ISRO, which are responsible for different purposes. So one such arm of ISRO is ISAC, or the Indian Satellite Center, and the name of the Indian Satellite Center, it has been changed, and it has been changed to UR Rao. Okay, UR Rao Satellite Center. UR Rao Satellite Center. So this Indian Satellite Center, or the UR Rao Satellite Center, it is its headquarters is in Bangalore. The headquarters of ISRO is in Bangalore, and the Indian Satellite Center, its headquarters is also in Bangalore. So please write that the Indian Satellite Center, or the UR Rao Satellite Center, it is responsible for fabricating. It is responsible for fabricating and designing of satellites. So the task of fabricating and designing the satellites, it is with the Indian Satellite Center. ठीक है, वी हैव इसरो इन बेंगलुरु एंड इसरो का एक काम है इंडियन सैटेलाइट सेंटर, उसका दूसरा नाम है यूआर राव सैटेलाइट सेंटर एंड दे आर रिस्पॉन्सिबल फॉर द फैब्रिकेशन ऑफ सैटेलाइट्स एंड फॉर डिजाइनिंग द सैटेलाइट्स। ओके क्लियर, सबने लिख लिया? ओके गुड, देन यस नितिन। ओके, I do not know Kritika. You are Rao. Basically, he was a scientist, and okay. So, in the honor of U R Rao, they have changed the name. Indian Satellite Center, ISAC. Sorry, it is the ISRO Satellite Center. ISAC is ISRO Satellite Center. Because it is one of the arm of the ISRO, and there is one more thing. First thing is the ISAC, ISRO Satellite Center, and second thing is it is the Vikram Sarabhai Space Center. Vikram Sarabhai, okay, Space Center. And this Vikram Sarabhai Space Center, it is located in, again in Kerala, Thiruvananthapuram. I guess Thiruvananthapuram is the constituency of Shashi Tharoor. Okay, so Vikram Sarabhai Space Center, and it is located in Thiruvananthapuram. So the primary purpose of Vikram Sarabhai Space Center is the development of launch vehicles. Okay, so the launch vehicles, they are developed at the Vikram Sarabhai Space Center. Okay, then there is one more institution which is known as Satish Dhawan Space Center. Satish Dhawan Space Center. And the Satish Dhawan Space Center, it is in Sriharikota. It is in Sriharikota. Sriharikota is a small island on the eastern coast of India. Okay, in Andhra Pradesh. It is a small island. You must have heard about the Pulicat Lake. And it is a small island at the edge of the Pulicat Lake. And this Sriharikota, it is the satellite launching station. Satish Dhawan Space Center, it is the satellite launching station of India, and it is situated on the eastern coast of India in Andhra Pradesh. Sriharikota is a small island. Okay, Vipul. Now the next thing is there is one more thing which is the Space Application Center. And this Space Application Center is in Ahmedabad. Okay, and here the research is conducted for the civilian use. It is basically for the research and development for civilian use. Okay, and there is one more facility under ISRO, which is the master controlling facility. The master controlling facility. And this master controlling facility, basically it controls we have a group of satellites which is known as GSAT. Okay, all of you must be having some idea about the geostationary satellites, and this GSAT, they are basically the geostationary satellite. So this master controlling facility, it is in the Hassan district. It is in the Hassan district of Karnataka. Hassan is in Karnataka. And there is one more master controlling facility which is in Bhopal, in Madhya Pradesh. So we have two master controlling facility. One is in Hassan, Karnataka, and the other one is in Bhopal, Madhya Pradesh. Okay, so they basically control the geostationary satellites. Okay, all the control is with this facility. The structure pretty clearly. And please write one more thing. There is one more arm of ISRO which is known as Antrix. Antrix is the commercial arm of ISRO. This is the commercial arm of ISRO. So we have all these facilities under the ISRO. We have the ISRO Satellite Center. ओके, इसका हेडक्वार्टर बेंगलुरु के अंदर है और वहां पे सैटेलाइट्स की डिजाइनिंग हो रही है. Even the fabrication and designing of satellites, it is done in Bengaluru in the ISRO Satellite Center, जिसका नाम चेंज करके अब UR Rao Satellite Center कर दिया गया है. And the second facility, it is the Vikram Sarabhai Space Center, and Vikram Sarabhai Space Center is in Kerala, Thiruvananthapuram. Okay, and there ISRO is developing the launch vehicles. Okay, launch vehicle का development Thiruvananthapuram में Vikram Sarabhai Space Center में हो रहा है. Then we have the Satish Dhawan Space Center, which is in the Sriharikota island of Andhra Pradesh. Okay, so it is basically the satellite launching pad, satellite launch pad of India, this satellite launching station of India. Then we studied about the Space Application Center, which is in Ahmedabad, where we are doing the research on the peaceful uses of space, okay, for the civil population. And then we have the master controlling facility, which is in Hassan district of Karnataka. They are controlling the GSAT. And there is one more such facility in Bhopal. Okay, so they are controlling the GSAT satellites. And finally, I told you about the Antrix, which is the commercial arm of ISRO. So, pura structure ISRO ka, I think it is in Bengaluru. I'm not sure, you can verify it later. But it is the commercial wing of ISRO, and I guess it is in Bangalore. So why do you think the most of these satellite launching stations, they are on the eastern coast? Do you see any logic in it? In most of the satellite launching station on the earth, they are situated on the eastern coast. Yes, the earth moves from west to east. They are on the eastern coast and they are nearer to the equator. Okay, so most of these they are near to the equator and they are on the eastern coast. So what kind of wind? In the equatorial region, we have the easterlies, the winds that are coming from the east. Okay, the winds, those are coming from the east, they are the easterlies. And so how will the easterlies help? So Sriharikota is somewhere here. Yes, Meenu, very good. Because at the equator we have the least gravity. Yes, Nathan, very good. The water bodies, okay. In case there is any accident, then the water bodies they will help, because any of the debris from the blast, okay, it will go to the ocean. It will go to the surrounding water. Now there are three reasons that most of the launching facilities, and in fact all the launching facilities, they are on the eastern side. Okay, they are on the eastern coast, and we have a water body on the eastern side. So reason number one is related to the gravity. Yes, Frankie, it helps in the initial boosting as well. Okay, so the gravity is inversely proportional to r square, the radius of the earth. Okay, and in geography you must have learned that the shape of earth is a geoid. ठीक है, ये तो पढ़ा है ना? This shape of earth, it is a special shape and we call it geoid. So earth is slightly bulged at the equator, okay, because of the centrifugal force. Why it is bulged at the center? It is because of the centrifugal force. So the equatorial radius, the radius of the equatorial region, it is more than the polar radius. Okay, when the r is more, the gravity will be less. The gravity will be less. Okay, so near the equator, the gravity is less. One reason is this. And the other reason is the earth is rotating from west to east, and in case of any accident the rocket will fall in the water, because on the eastern coast the rocket is already, because the earth is moving from west to east, the rocket, it also has this velocity, and if there is any accident, then the chances are there that it will fall in the water body. Okay, so this is the second reason. And third reason is that the velocity is maximum at the equator. The rotational velocity of earth, it is maximum at the equator, because v is equals to r omega. ये फॉर्मूला सबको पता है? See, this is the earth, and if this is the rotational axis of earth, the earth is rotating about this axis, okay, and the greater circle, this greater circle is the equator. So there is a circle which is basically rotating around the axis of the earth, and this is the largest circle. Then we have all other smaller circles. Okay, so this circle, it will be smaller than the equatorial circle. Very well. So if we move further away from the equator, the velocity, it will decrease, because r is decreasing. Here r is the distance from the axis of earth. Okay, ये वाला distance अब यहाँ पे r है, and earth is rotating about this axis, so this is the angular velocity, and it is same for the entire earth, but the speed of different latitudes, they are different. Okay, omega is same and r is reducing. The distance from the central axis, it is reducing, and at the pole, at the polar region, this distance is 0. Okay, so the velocity is maximum at the equator, and it will add to the orbital velocity of the satellites. Here it will add to the orbital velocity of the satellites as well. सबको समझ में आया? It will add to the orbital velocity of the satellites as well. ये भी समझ में आया ना? Why the different latitudes they are having different speed? And basically this difference in speed is the precise reason for that Coriolis effect. Sorry.
So why is this adding to the orbital velocity essential?
So if you are moving in a train, okay, then you are moving at the velocity of the train. Since our facility is located at the our facility is located on the earth, so it is moving from west to east at the speed of the earth. Clear?
Yes.
And the speed of the earth, it is more near the equator.
Yes.
So that is why it will add to the eastern velocity of the aircrafts that we are launching.
So, but like, why is that necessary? Like, why is it required?
The physicists, they can always manipulate this initial velocity. Suppose Earth is rotating from west to east, Earth is rotating from west to east. So already we have the velocity of the Earth. Our facility is moving in this direction with the Earth. Okay, so already our spacecraft has this initial velocity. Agree? And by burning the fuel inside the aircraft, we are giving it a vertical velocity.
Yes.
Okay. So vertical velocity is provided to the aircraft by burning the fuel. And we already have this eastern velocity. So this will be the net velocity by the vector addition. This will be the net velocity of the aircraft. So scientists, they manipulate this additional speed to inject the aircraft in the desired orbits.
Okay.
And how they do it? It is technically the rocket science. Okay, we normally use the phrase rocket science. This is rocket science.
Yes.
Now, we have different types of launch vehicles to place the satellites in the orbit. And I have already told you that which facility develops the launch vehicle. Which facility develops the launch vehicle? अभी बताया है.
Sarabhai.
Yes, it is the Vikram Sarabhai Space Center, which is in Thiruvananthapuram. Okay, so we have a lot of different kinds of launch vehicle. The first kind is the satellite launch vehicle, normal the satellite launch vehicles. Okay, they can carry a payload with them of 50 kgs. So initially we developed the satellite launch vehicles which can carry only the weight, only 50 kg of luggage or payload we can say with them. The term is payload. Then we have the augmented satellite launch vehicle, ASLV. A is for augmented. Okay, we have the augmented satellite launch vehicle and they can carry up to 150 kgs. Then we have the PSLV, the Polar Satellite Launch Vehicle. And Polar Satellite Launch Vehicle, they can carry payloads up to 1 ton. And this Polo satellite launch vehicle, they are known as the workhorse of ISRO, क्योंकि सबसे ज्यादा सैटेलाइट्स इन्होंने ही इसरो के लिए लॉन्च किए. The record number of successful satellites, they have been launched by PSLV, the Polo satellite launch vehicle, and they can carry the payload up to 1 ton. Then the next category is GSLV. Okay, GSLV, they carry the weight in the range of 1 to 5 tons. Okay, and there is one more satellite launch vehicle which is GSLV Mk3, and this GSLV Mk3 is basically, it can carry up to 10 tons. Okay, it depends upon in which kind of orbit, okay, we want to place these payloads. So there are several kinds of orbit and we will discuss them later. Okay, if the weight is less, they can even transfer them to the higher orbits, and if the weight is more, they can at least, G is the geo satellite launch vehicles, P is the polar satellite launch vehicles, okay, or the geostationary satellite launch vehicles. ओके, स्पेस प्रोग्राम को हम किस तरीके से कर रहे हैं, बेसिकली इसरो का एक स्ट्रक्चर, ओके, वी आर ट्राइंग टू अंडरस्टैंड द स्ट्रक्चर ऑफ द इसरो एंड द एम्स ऑफ इसरो and these different arms of the ISRO. Then obviously all the programs that are in news, they become important from the exam perspective. Okay, so the ISRO launches so many programs and they become important from the exam perspective. You can already you can always remember them, that is the factual information, but this is the basic structure of ISRO, and we will also study the basics of the orbits, and then you can always grab that factual information that is coming in the current affairs. Okay, सबको बात समझ में आई? Then ISRO is also working on, I told you about the PSLVs, I told you about the GSLVs. Okay, the difference between them is how much load they can carry with them. Okay, so we are advancing our technology, and ISRO is also developing one more kind of engine which is known as the scramjet. Okay, so this scramjet engine, it is known as air breathing propulsion system. Air breathing propulsion system. The tagline for this scramjet is air breathing propulsion system, and it is called so because it can utilize the atmospheric oxygen when it is in the upper part of the atmosphere. It can utilize the atmospheric oxygen as a fuel. ठीक है, सबको बात समझ में आई? Higher in the atmosphere, it can take up the atmospheric oxygen and it can use it as a fuel. So in this scramjet engine, we use the hydrogen gas as a fuel, and the oxygen it will take up from the atmosphere. But for rest of the launch vehicles, what we do is, okay, we mix the fuel with some oxidizing agent, oxidizer. The rest of the rockets, they work on the fuel plus some oxidizing mixture. Some chemical will be added to the fuel for the supply of oxygen. Okay, in the combustion we require oxygen, but this scramjet engine, it can utilize the atmospheric oxygen. Okay, it is in the developmental phase and we are not still using it commercially, but it is in the developmental phase. Okay, सबको बात समझ में आई? And with this scramjet, we can fly at the hypersonic speeds. हाइपरसोनिक कोई बताएगा व्हाट इज हाइपरसोनिक? Yes, Soumya, very good. Hypersonic means the speeds which are, yes, Disha, faster than the speed of sound wave is the supersonic, and hypersonic is greater than Mach 5. So this is the 1 Mach means equal to the speed of sound, okay, and 5 Mach is 5 times more than the speed of sound. So the hypersonic is which is greater than Mach 5, 5 times more than the speed of sound. Okay, so with this scramjet engine, we can fly at Mach 5. Scramjet is used, I don't know. That scramjet is used in the Rafale. So Disha is saying that the scramjet engine is used by the Rafale aircraft. So that is a very good factual information. You can note it down that the Rafale is using scramjet engines. Are you sure, Disha? Are you sure about it?
Yes, I read it before when the
Okay.
article was being published in the Hindu newspaper about the Rafale.
Okay. Okay, very good, Disha. So this is the air breathing propulsion system, and ISRO is developing it indigenously. So now the different kinds of orbits. Okay, so we have various orbits. One orbit is known as the geostationary orbit, and when we have the polar orbits, and then we have the geosynchronous orbits. If this is my Earth, and this is the North Pole, and this is the South Pole, then the orbits which passes across the poles. Okay, the orbits which passes through both of these poles, they are known as the polar orbits. Okay, so these kind of orbits, they are polar orbits. Clear? So these polar orbits, they are along the longitude. Okay, these polar orbits, they are along the longitude, and the Earth is rotating from west to east. Okay, so the satellites which are in the polar orbits, they can view the entire Earth, because Earth is rotating in this manner, and these satellites are encircling the Earth in this manner. Okay, so they can view all of the Earth. Okay, because the Earth is rotating, so all of the Earth can be viewed by these satellites. So we have the polar orbits, and the satellites which are in the polar orbits, they are known as the polar satellites. Then we have the geostationary satellites. So geostationary satellites, they are those satellites which are parallel to the equatorial belt. They are parallel to the equatorial belt, and their period of rotation is equals to the rotation of the Earth. The rotation of Earth is equals to the period of rotation of these satellites. So every time these satellites, they remain overhead. the rate at which the Earth is rotating, the Earth is completing its full circle in 24 hours. Okay, so these satellites in their orbit, they will complete their full rotation in 24 hours. So if we view them from the Earth, we see them as stationary. Okay, they are not moving. They are overhead. Okay, they are above us all the time. So these are the geostationary satellites. Very well. Then we have other satellites which are known as geosynchronous. Parallel to the latitude. Okay, the largest latitude is the equatorial latitude. Equator is the 0 degree. What is the 0 degree? We are talking about the 0 degree latitude. Okay. And the period of rotation is the same as the rotation of the Earth. So they remain overhead, okay, all the time. So such kind of satellites will be used if we have to cover only one particular area of the Earth. And if you want our satellite to cover all of the Earth, then we will place it in the polar orbit. But if you want our satellite to cover a particular area, okay, then we will use the geostationary satellites. So all of you must be okay using the Tata Sky at your home. Okay, Tata Sky or Airtel Dish TV. You might be using all these. So the antenna of the Tata Sky, it always points in one direction in the sky. Okay, it basically looks for one such satellite, okay, communication satellites, which transmits the data to the antenna of the Tata Sky. So because your Tata Sky, it always points in one direction, basically it points in the direction of one such satellite which is sending the signal to the Earth. Is it clear? Then we have the geosynchronous orbits, geosynchronous satellites. These are those satellites. For these satellites also, the period of rotation of these satellites is equal to the rotation of the Earth. Okay, but in this case, in the case of geosynchronous satellites, this is my equatorial plane. In these orbits, they make some angle theta with the equatorial plane. Okay, so these orbits are tilted with respect to the equatorial plane, and the geostationary satellites, they are basically parallel to the equatorial plane, and they are tilted at some angle with the equatorial plane. For both of them, the period of rotation is same as that of the Earth. So basically, we can say that the geosynchronous is a broader term, and geostationary, okay, it is a special type of geosynchronous satellite for which theta is 0. If theta is 0, this will be parallel to the equatorial plane. Okay, so those geosynchronous satellites for which theta is 0, they are the geostationary satellites. Clear? Very good. I will come to that later on. I will talk about the distance from the Earth crust. Geosynchronous satellites, okay, we use them if you want to cover any other specific area of the earth. Okay, if you do not want to cover just one latitude, geostationary satellite, they will cover only one latitude. But with the geosynchronous satellites, we can cover the several. Yes, basically they use the GSAT satellites, Ruxana. For the satellite communication, we are using the Tata Sky, the broadcasting of the cricket matches. For those, we are using the GSAT satellites, GSAT series of satellites, or we use the INSAT series of satellites. And both of these satellites, the category of these satellites is they are geostationary satellites. Because they regularly have to beam information in one particular direction. Okay, that is the main purpose. And it does not mean that we cannot use any other satellites, okay, for providing this information. But for the 24/7 connectivity, okay, we place them in the geostationary orbit for the 24/7 connectivity. You can switch on your Tata Sky even at night, okay, it works 24/7. If this is the Earth's surface, this is the surface of the Earth. Then we have a class of orbits known as the low Earth orbit. Okay, so these low Earth orbit, any orbit below 2000 kilometer is a low Earth orbit, or it is mostly in the range 600 to 2000 kilometers. This is the low Earth orbit. And majorly in the low Earth orbits, we place the remote sensing satellites. Remote sensing satellites they are placed in the low Earth orbits. Then we have the geostationary Earth orbits. Geostationary Earth orbits, they are basically, their distance is 35,786 kilometers above the equator. Okay, 35,786 kilometers above the equator. And in between, we also have the medium Earth orbits. And the orbits which are very closer to the Earth, we can classify them as the near Earth orbits. But basically, these two are mostly used. The geostationary Earth orbits, and this is used for the communication satellites majorly. And the low Earth orbits, they are used for the remote sensing satellites. Okay, ये clear है? Very good. Now these remote sensing satellites, what are these? They are basically the Earth observation satellites. They're kind of Earth observation satellites. Okay, if you want to map the surface of the Earth, okay, even if we are using these for the military purposes, for the surveillance purposes, so we will be using these remote sensing satellites. If you want to map the crop area, the agricultural crop area, the forest cover, okay, so everything it will be mapped using the remote sensing satellites. Okay, in order to map the geography of the Earth, we will use these remote sensing satellites. So the collection of information regarding the agricultural crops or for the military uses, or even to detect the forest fires, or to collect the data of the climate. Okay, the data related to climate, like the concentration of various gases. So for of all of these purposes, and for to find the the minerals, in which belt we can find the minerals. So for these kind of activities, the remote sensing satellites, they are used. It is clear? Is it clear? So we can use them in agriculture. Okay, we can use them in mapping of terrain. The military can use it for surveillance. Okay, and also they can even detect the forest fires. So all of these things we can do it with the satellites. Because they can even track the pest activity inside the agricultural fields. They have powerful instruments. Okay, powerful instruments are attached in these satellites, and they are using obviously the electromagnetic waves. So they can track they can track the green cover. Okay, so from that data they can infer even the pest activity. They are very powerful satellites. Okay, Nikhil, welcome. So these INSET series of satellites, I talked about the INSET series of satellites, which are the geostationary satellites. So this INSET series, it was developed. Okay, obviously ISRO is there, or the Department of Space is there, and plus we have the All India Radio. Okay, plus the Indian Meteorological Department. Okay, and plus we have the Doordarshan. So this was a collaboration of all these. Department of Space, and Department of Space is represented by ISRO, and we have the All India Radio, Indian Meteorological Department, and we have the Doordarshan. So this INSET, it was multi-purpose satellite, and we were using it for obviously the telecommunication and communication purposes, for the broadcasting purposes, and we also use the INSET for the search and rescue operations. Okay, it was the multi-purpose satellite in the geostationary orbit. And remote sensing. INSET series of satellite, basically it is the communication satellite which is placed in the geostationary orbit, and we used it for the broadcasting, okay, telecommunication, and we used it for search and rescue operations. Okay, All India Radio and Doordarshan, they are broadcasting their information using the INSET series of satellites, and your phone, my phone, okay, all of these use the INSET series of satellites. And remote sensing satellites, they are basically used for mapping purposes, mapping the land surface area. Now we have different categories of fuels, and different categories of fuels are, we have solid fuel, liquid fuel, and we also have the cryogenic stage, and I will talk about all of these fuels. So we have this. So INSET, it will be inserted in the orbit at a distance of 35,786 kilometers. Okay. Then I told you about the satellite launch vehicle. Then I told you about the augmented satellite launch vehicle. Okay. And all of these were using the solid fuel. All of these were using the solid fuel. Then the next launch vehicle was the PSLV. And PSLV, it was using the fuels in 4 stages. It is basically a 4-stage engine. What is PSLV? It is 4-stage engine. Okay. So first one is the solid stage. Then it uses the liquid fuel. Then again it uses the solid fuel in the 3rd stage. And finally it uses the liquid fuel. So we have the solid, liquid, solid, liquid. Okay, PSLV, it is a 4-stage launching vehicle. Basically the 4-stage engine. And then we have the GSLV. So the GSLV is using GSLV. The first stage is the solid. First stage in all of these is solid. Nikhil, the satellites, they use the battery and solar energy to power the equipments that are on board the satellites. Okay, there are certain spectrometers, there are certain cameras with the satellites, and in order to power them, we need the batteries and the solar panel. Okay, but the fuel is needed to provide the thrust. Okay, the fuel is needed to provide the thrust to put the rocket in the outer space. Okay, Nikhil. I don't see any big difference in precision and accuracy. Rishabh, what specifically do you want to ask?
Actually, I read it somewhere that,
Okay.
as you said, I agree to it that there is no such difference and that there is a minor difference, but I did not understood the meaning of precision here.
Precision is basically like I told you that the LIGO detector, it can measure the 1000 part of the diameter of a proton. Okay, so this is the precision of the instrument. वो इतना measure कर सकता है. That is the precision of the. Okay. Or alternatively, we can say that the accuracy level of the instrument is this. We cannot measure lengths which are less than this. Okay, precisely we can measure only this much length or any integral multiple of this length. So obviously the actual meaning, it will be clear only from the context. You have to see the context in which the word is used.
Sir, can I add something to your answer?
Yes, Deep, please.
Sir, the difference is like we want to shoot at the 0.00. Consider it.
Okay.
And
Okay.
if the gun is shooting exactly at 00, then it is accuracy. And the precision is about repetition. Like if the gun is shooting at 0.101, and if again it is shooting at 0.101 repeatedly, then it is precision. And the first thing is accuracy.
Okay. So I don't think there is any major difference. Okay. It would be clear only from the context in which the word is used. I think Nitin has given a better description. Okay, precision is I think the minimum that we can accurately say. The minimum level of accuracy is precision. I guess so. I was talking about the fuel. I was talking about the GSLV. In GSLV, Okay, in the first stage we use the solid fuel, and in the second stage we use the liquid fuel. Second stage is liquid fuel is burned, and the final stage is cryogenic. Okay, it is clear. In the PSLV we are using the solid, liquid, solid and liquid. And in case of GSLV, we are using the solid, then we are using liquid, and finally we are using the cryogenic fuel. Or the third stage is the cryogenic, second stage is the liquid stage, and the first stage in all of these rockets is the solid stage. And there is a reason that the first stage is always the solid state. Yes, we can say, but I don't think so there is any specific difference in precision and accuracy. We use them interchangeably. So we have the solid fuel. There are some properties of the solid fuel. The one property is that it burns rapidly. Okay, it burns rapidly, and because it burns rapidly, it generates thrust in a smaller time. Okay, it generates the thrust instantly because it burns rapidly. And second thing is that it is cheaper. Okay, and there is one more thing, that these are less corrosive and they are easy to store. They are less corrosive, and because they are less corrosive, they can be easily stored. And for the reason that they are less corrosive, they have higher shelf life. Okay, they can be stored for a longer time. But there are also certain disadvantages. So these are the advantages: they burn rapidly and they generate enough thrust, okay, to lift the rocket. And second is they are cheaper. Third is they are less corrosive and they have higher shelf life. But there are also certain cons, certain disadvantages with the solid fuels. They are bulky. They need enough storage volume. Okay, they need huge volume for storage. And once they start burning, okay, we cannot stop the combustion. Okay, once they are ignited, they will burn until they are exhausted. So एक बार इनको आपने स्टार्ट कर दिया, इग्निशन इसमें स्टार्ट हो गया, तो जब तक फ्यूल कंप्लीटली बर्न नहीं हो जाएगा, we cannot stop it. So once ignited, we cannot stop them. Clear है solid fuel का? They are bulky, they need huge space for the storage. Okay, और फ्यूल का ही इतना वेट हो जाएगा क्योंकि we have to escape the gravity, and to escape the gravity we need huge amount of thrust, and for that we need the huge amount of fuel. तो पेलोड के लिए जगह ही नहीं बचती है. ओके, जितना ज्यादा बल्कि फ्यूल होगा पेलोड के लिए उतनी कम जगह होगी. In fact, the 50% weight of the launch vehicles, it is the fuel. Okay, sometimes even the 50% weight of the vehicle, it is just the fuel. And then we have the liquid fuel. In case of liquid fuel, they produce more thrust than the solid fuel. Okay, but it takes time. It takes them time to to ignite. It takes time to ignite them, and they offer flexibility. Flexibility in the sense that if they are ignited once, then they can be stopped. If you ignite them, then you can also stop them, and only some part of the fuel will be burnt. Okay, the rest it will be spared. So we can stop the ignition after burning some part of the fuel. So liquid fuel is helpful if we have to maneuver the velocity of the aircraft. Okay, if you want to slow down the aircraft, if you want to maneuver we have to shut the engines off. Okay, and we can shut off the engines in case of the liquid fuel. We cannot do it with the solid engines. The engines that are using the solid fuel, we cannot switch off our aircraft. But with the liquid fuel, we can switch off the aircraft, we can switch off the engine for some part of the time. Clear? And they are also less bulky. They are less bulky than the solid fuel. Okay, but they are more corrosive than the solid fuel. This is their one disadvantage. They are more corrosive than the solid fuel. Okay, so सबसे बड़ा एडवांटेज लिक्विड फ्यूल का यही है कि एक बार हमने इग्नाइट कर दिया, उसके बाद हम अपना इंजन स्विच ऑफ कर सकते हैं, फ्यूल की बर्निंग स्टॉप हो जाएगी और फिर हम उसको दूसरे टाइम पे स्टार्ट कर सकते हैं. सो इसकी हेल्प से वी कैन मैन्यूवर द वेलोसिटी ऑफ द स्पेसक्राफ्ट. And then we have the cryogenic fuel. So in case of the cryogenic fuel, they use the minimal space. Okay, they use the minimal space and they produce thrust which is 1.5 times more than the solid or liquid fuel. Okay, they produce thrust which is more than 1.5 times than the solid fuel and the liquid fuel. So the efficiency of the spacecraft, it is measured by a performance index of rocket. We have a parameter known as the performance index of rocket. There is a parameter which is the performance index of rocket, and it measures basically, it is the ratio of thrust generated per kg of fuel. When you burn the 1 kg of the fuel, what is the thrust generated? Okay, so the cryogenic fuel, it is 1.5 times, it generates the thrust 1.5 times more than the solid and liquid fuel. And the cryogenic fuel that we are using, it is the liquid hydrogen gas at a temperature of minus 253 degrees Celsius. Okay, liquid hydrogen at minus 253 degrees Celsius. Please write the meaning of cryogenic. Cryogenic is the study of behavior of material at very low temperatures. Cryogenics relates to the study of behavior of materials at very low temperature. Okay, so in the GSLV, the upper stage is the cryogenic. And India is working from the 1990s on the cryogenic upper stage, and we have developed this technology. No, it is not about the cost. In fact, okay, the technology, it was in the developmental phase. It was not about a choice because the technology was still in the developmental phase. Okay, but it offers more thrust. Okay, and it can be shut down. And there is one more thing: it occupies less volume because the hydrogen, it will be in the liquid form under the compression. So when the liquid hydrogen is released, okay, its volume increases 100 times. When it is so, we can store the more amount of fuel in the lesser volume. It is also one advantage. Okay, but there were some issues with the development of the technology, and that is why we were not using it. So the cost issues, they are not there. Cryogenic is a better technology.
Sir, technology issues in India or all over the world?
No, India is trying to develop it indigenously. The other countries, they have the cryogenic technology with them.
Sir, so in practice, all over the world, cryogenic technology is being used.
See, all over the world, the manned mission to the space or to the moon, there are only three countries. We have the US, we have the Russia, USSR, and we have China.
Yes, sir.
Okay, so they have the advanced cryogenic technology, and India is indigenously working on the cryogenics. Okay, and we have developed GSLV MK3.
Okay, sir.
Okay, so this is all about the ISRO Indian Space Research Program and some of the basics about the fuel, about the orbits and the launch vehicles. Now in the newspaper, you will see the different space programs that are launched by ISRO, okay, and that are launched by the NASA. So they become important from the exam perspective. Now that I have given you some basic idea about the orbits, what are the geostationary orbit, what is remote sensing satellite, and what are the communication satellites. So it will be easier for you to comprehend the data from the current affairs. Okay. Now Nathan, they are entirely different fuels. In the cryogenic stage, we are using the liquid hydrogen, but in the solid fuel, we are using, okay, like in liquid fuel, we use the dimethyl hydrazine. I did not made you write them because I don't think, okay, UPSC will ask them. I don't think so. The UPSC, they are not asking the high school biology. Okay, for the last 6-7 years, they have not asked the high school biology, or they have not asked about any of the chemicals. So I do not want to give you this stuff that is, okay, in my opinion, that is not important, and I am telling you something from my experience. So I would say you can trust me. But the liquid fuel is like the dimethyl hydrazine, and in the solid fuel there is some other chemical. So there are different chemicals. Like we have all these missions of ISRO. We have Gaganyaan, we have Chandrayaan 1, Chandrayaan 2, we have the Mangalyaan, we have this Navik constellation of ISRO, the space station by ISRO. Okay, the International Space Station, it is basically a habitable satellite and it is in the low Earth orbit at 2000 kilometers. So we have all these missions, and these are basically the space program of ISRO, and we are using them only for the peaceful purposes. Okay, as the vision of Vikram Sarabhai stated, we are using them only for the peaceful and civilian purposes. And these are some of the space programs of NASA. Cassini, it was to study the Saturn, and we have the Juno to study the Jupiter, the Messenger for Mercury, Curiosity rover for Mars, and obviously the International Space Station. Okay. So this is only factual data. It is usually asked in the examination, but once you know the basics of any topic, you can remember it for a longer period of time. And that basic knowledge, it will help you in your mains examination. Okay. So we will be doing some of the space missions. And first one here is we have the Gaganyaan. So India is planning to launch its first human space mission, and it is scheduled to be launched in 2022. Okay, because it is a manned mission, and obviously they have to re-enter the atmosphere as well. So here the payload is more. Okay, here the payload is more, and for this reason we are using the GSLV Mk3 vehicle for it. We have developed the GSLV Mk3 vehicle, and okay, it can lift up to the 10,000 kgs or 10 tons in the low Earth orbit. So Gaganyaan, it is scheduled to be launched in 2022. GSLV Mk3 will be used, and the total cost of mission is 9,000. And ये cost कहाँ से आई होगी? Who will fund it? Yes, the Department of Space, it will fund it. Okay. The mission will have 3-member crew of the astronauts. So we are sending 3 people to this space. Now 4 of the members who have been selected for this space mission, इनमें से एक रह जाएगा क्योंकि 3 को ही भेजना है. So they are undergoing training in Russia. They are undergoing their 11-month training in Russia, and 4 of them have been selected for the human space missions. And if India will be successful in this, then it will be the 4th country to send humans in space. I already told you that USA, China and Russia, they have done it on their own. Okay, the Indians, they have been to space, but they didn't go to the space on an Indian spacecraft. We have the Kalpana Chawla, we have Rakesh Sharma. Okay, we went to the space on the aircrafts of NASA. So this crew capsule, it will weigh around 7,000 kgs, and this human space flight center, they have its headquarters in Bengaluru, and it has been tasked to complete this mission. Okay, there will be some upgradation at the launch pad of Sriharikota. Have you seen the location of the Pulicat Lake on the eastern coast? Okay, when you will go through the atlas, okay, try to look at this island Sriharikota. It is a small island at the edge of the Pulicat Lake, and it will be upgraded to launch the Gaganyaan. Okay, it will be established in the lower Earth orbit at an altitude of 2,000 kilometers. Now, there is one more concept. Why do we have the zero gravity in this space? Okay, let me explain the zero gravity situation. If this is my Earth, okay, and this is the orbit around the Earth, and suppose this is International Space Station, and in the International Space Station we will have the zero gravity situation. Disha, you are asking Vyomitra will also be the part of Gaganyaan mission. I will confirm it, Disha. I have no idea that if we are planning to send the Vyomitra to the space as well. So if a satellite is orbiting the Earth, okay, this is the Earth, and suppose we have humans inside the satellite, then the satellite is attracted towards the Earth by the force of gravity. Okay, Gravity is attracting the satellites toward it, and this is moving in this orbit at a greater velocity v. Okay, so this satellite is bound to the Earth system, and the gravity is providing the centripetal force. You know the difference between centripetal and centrifugal? Okay, so this is the gravity is providing the centripetal force, and because of this force, the satellite is bound to the Earth system and it is rotating around the Earth. अब ये जो ग्रेविटी की फोर्स है ये सैटेलाइट को कहीं जाने नहीं देगी and it will keep on revolving around the Earth provided इसके पास right velocity हो. और ये right velocity कहाँ से आती है सैटेलाइट्स के पास? Okay, we fire the engines. That is why liquid stage or cryogenic stage is necessary. We fire the engines intermittently to give them the precise speeds that are required for a given orbit. एक ऑर्बिट के अंदर एक रिक्वायरमेंट होती है एक वेलोसिटी की, and that velocity is granted by firing the engines intermittently. Okay. So because of the rotation, there is also a centrifugal force because it is rotating in a circle around the Earth. So because of the rotation, we have a centrifugal force. In the rotating system, we always have the centrifugal force. Okay, so इसके अंदर जो human being है, the human inside the satellite, okay, he is attracted by the gravity. He is experiencing the force of gravity, and there is an opposite and equal force of centrifugal force because of the rotating system. So the gravity, it is cancelled by the, it exactly matches the centrifugal force. So the net force that is acting on this person inside the satellite is 0. Okay, since no force is acting on the person inside the satellite, he feels weightlessness. जब आप weighing machine पे खड़े हो तो then because of the gravity you are pushing the weighing machine. Okay, and you have some weight. But in case of the space, the force of gravity, it is exactly cancelled by the centrifugal force because both are oppositely directed, and net zero on you will be 0 and you feel light. That is the weightlessness inside the satellite. Clear? Though we are in the influence of the gravity inside the spacecraft, but still we feel the weightlessness. Then I said that the satellite, it is rotating around the Earth. Okay, and if there is person inside the spacecraft, he is attracted by the force of gravity, and because the satellite is rotating, there is an equal force opposite to the force of gravity, which is the centrifugal force. Centrifugal, and gravity is providing the centripetal force. So these two forces, they cancel each other, and the net force F net acting on the person inside the spacecraft is 0. And for this reason, the person, okay, he has this condition of weightlessness. Okay, it is not that the gravity is 0. The gravity is non-zero, but the gravity is balanced by an equal and opposite force. So the person feels that F net is 0 and he feels that he is weightless. And I have already explained the polar orbits. Okay. So if the axis of the orbit of a satellite, it passes through the pole of the Earth, then it is a polar orbit. Axis pass हो रही है through the poles, so this is a polar orbit. And then we have the geosynchronous orbit. If the time period of movement of satellites, it is synchronized to the rotation of the Earth. Okay, the time period of the rotation of the satellite and the time period of rotation of the Earth is same. Then we have the geosynchronous orbits. Okay, and in geostationary orbit, if any geosynchronous orbit is in the plane of equator, it is called the geostationary orbit. अभी मैंने थोड़ी देर पहले बताया था that geosynchronous is a broader term and geostationary, okay, this is a narrow term. So geostationary satellites, they are the special geosynchronous satellites which move in the equatorial plane. So in this diagram, this is the geostationary satellite in the equatorial plane, and with respect to the equatorial plane, okay, there is some angle in case of geosynchronous. So this is the geosynchronous and this is the geostationary. Now the Chandrayaan-1 mission, and we have some factual information regarding the Chandrayaan-1. This was launched in October 2008 and it was operational till August 2009. ऐसा क्या हुआ होगा 2000 अगस्त 2009 में? फ्यूल खत्म हो गया होगा. Okay, so it was launched on the PSLV C-11. Yes, solar panels, they will be there. But they will be operational only for some time. See Harini, PSLV C12311, it is basically the sequence. Okay, the sequence of launch, it goes on like 30, 31, 32. So every attempt, it is okay. We name it in the chronological order. If after the C11, the next launch of the PSLV, it will be termed as C12. After the fuel is exhausted, okay, it will roam in the free space. The things which are rotating in the orbit, they will keep on rotating. Now your solar panels, they run on the battery, okay, and the batteries, they have a life, and anything can happen in this space. Okay, they cannot work indefinitely. In this space, when there is no radiation, when a satellite is in this shadow zone, then the temperature, it drops to, okay, minus 250 degrees Celsius in the shadow zone. And when the any satellite is in this in the direct contact of the sun ray, then the temperature, it can rise to up to 200 degrees Celsius. So the materials, they have to sustain this much of range. Okay, there is a huge temperature range, and there is a wear and tear of the material. Okay, there is a wear and tear of the material, and like when any aircraft, it enters the Earth's surface, the temperature, they rise to as much as 2000 degrees Celsius because of the friction. So we have to develop the re-entry module in such a way that can sustain those high temperatures. Okay, on the Earth, the temperatures, they do not drop very drastically because of the atmosphere of the Earth. We have the greenhouse gases, and because when the Earth radiates back the heat, it gets trapped by the CO2 present in the atmosphere and other greenhouse gases. The life of the equipment, okay, That is a different thing. But the satellite, once it is inserted in the orbit, it will keep on rotating in that orbit. So in this space there is no atmosphere, and when there is shadow, when we do not have any light in that portion, the temperatures they drop drastically up to 250 degrees, minus 250 degrees Celsius. And if you are in the solar zone, okay, you are receiving the sunlight, then temperature they can rise to 200-300 degrees Celsius. Now Chandrayaan, it was launched in October 2008 and it was operational till August 2009. It was launched on the vehicle PSLV-C11, and there were certain payloads on the Chandrayaan 1 for the mineralogical and for the mapping of the lunar topography. Okay, there were high resolution spatial cameras to map the topography of the moon and to map the minerals present on the lunar surface. And 95% of the objectives they were achieved. Okay, and in the Chandrayaan 1 we found the traces of water on the moon. So those were some of the achievements of the Chandrayaan, and you can prepare some data in the like in the main syllabus GS3 we have the achievements of Indians in science and technology. Okay, so this can be one achievement and you can remember this. Then the Chandrayaan 2, it was launched last year in July 2019, and we used the GSLV Mk3 M1. And Chandrayaan 2, it consisted of an orbiter, a lander, and a rover. Okay, orbiter basically that will keep on rotating in the orbit around the moon, and the lander, okay, which will touch down the lunar surface, and the rover, after the touchdown, the rover, it will do its work of collecting the sample. Okay, the sample of the moon soil. So the name of the lander, it was the Vikram, and name of Pragyan, it was rover. So all these kind of factual information, it can be one of the statement in the prelims examination. Okay, but I think you will be giving exam next year, so this information, it will become irrelevant for you. Now the main objective of the rover, it was to study the composition of the surface near the lunar landing site and determine its abundance of various elements. Basically they wanted to search for different kinds of elements, and this was planned to near the South Pole. They plan to land it near the South Pole of the moon. Okay, because that portion of the moon is unexplored. And this mission, it failed. Okay, last year it failed. Modi ji gaye the ISRO director को सांत्वना देने के लिए, and this mission failed because of the velocity issues, because we were not able to reduce the speed of the aircraft. Okay, there was some issues with the speed of the aircraft and we could not bring down the speeds, and it crashed during the touchdown. So only 3 countries they have successfully landed on the moon. Again, these are US, Russia and China. So we will reattempt, okay, the Chandrayaan mission, and it will be the Chandrayaan 3, and we will do it in the second quarter of 2021. Okay, the 1 year before the Gaganyaan mission of 2022. Now this is the NAVIC, or it is Indian Regional Navigation Satellite System, and this is also known as NAVIC, and this acronym, it was given by the Prime Minister Modi, and the NAVIC is Navigation with Indian Constellation. So this NAVIC is a constellation of 7 satellites, and 3 satellites they will be placed in the geostationary orbits, and 4 of the satellites they will be placed in the geosynchronous orbits. Okay, so we have a constellation of 7 satellites in the space, and these satellites, it will be used to provide the accurate position, the position information services to the users in India. So basically what we are doing to do is we are trying to create our own version of GPS. Okay, this Navik is our indigenous GPS, and it will cover the area of all of India and 1500 meters from our boundaries. Okay, the regions extending up to 1500 kilometers from our boundaries, it will all be covered by Navik. So we can using it spy on Pakistan. So what are the applications of Navik? So we can use it in the navigation, be it the marine navigation, aerial navigation, or on the land part. And obviously it can be used in the disaster management, in the vehicle tracking and fleet management, and the precise timing of the movement. And there is one information that we have the Chinese mobile manufacturer Realme, and it will have the Navik feature, Navik navigation feature in their cell phone. So this company Qualcomm, they have also created, okay, the chips having the Navik feature, meaning the processors, those have the Navik features. So Navik will be, again, it will be used for the mapping, and this geodetic data, it is the data regarding the, again, the surface of the earth, the structure of the earth. And it will help the hikers who go to the mountains, okay, to scale the higher mountain peaks. So for all these people, they can use the Navik and the visual and voice navigation for the drivers. So basically this is Desi GPS. Now this question was asked in the UPSC prelims, and I guess it was asked in UPSC prelims 2016. And the statement 1 says the IRNSS, it has 3 satellites in geostationary and 4 satellites in geosynchronous orbits. So the statement 1, it is, statement 1 is, yes, statement 1 is correct. And the second statement is, it covers entire India and about 5500 square kilometer beyond its border. अभी हमने पढ़ा है that it covers only 1500 kilometers from its borders. Okay, so 2 को eliminate करने से 2 ऑप्शन तो यहाँ पे वैसे ही eliminate हो गए. Okay, and the third statement is India will have its own satellite navigation system with full global coverage by the middle of 2019. So this statement is also wrong. We are covering only the regional South Asia. So statement 1 is correct. Okay, so in the prelims examination, the factual information, it matters. Okay, the factual information matters. That 5500 square kilometers, and basically यहाँ पे तो उन्होंने square kilometer भी लगा दिया. So UPSC is giving you hints that this statement is wrong. And statement 3, okay, this is all obviously wrong. So this was an easy question in the UPSC prelims examination, and it was asked again because the Navik, it was in use. It was in news, and it was in news frequently. Okay, nowadays Navik, it is not in use. I think 1 or 2 years back it was in news because one of the atomic clocks on one of the satellite, it was not working. So for that reason it was in news, because we lost the contact with that satellite. But एक बात ध्यान में रखनी है, जो चीज न्यूज में जितनी ज्यादा होगी उसी के आने के चांसेस ज्यादा होते हैं, और उसके रिगार्डिंग फैक्चुअल इंफॉर्मेशन पे ध्यान देना होता है. ओके, Now there are other navigation satellites across the world. We have the GPS. GPS is of US and it started working in 1973 for the US military. Okay, and it is being used for the civilian purposes. Navik is working. Only one of the satellite it was not working, and okay, we have the replacement for that satellite also. And if it is not working, we cannot know it because government will not give that information to us. Okay, we get only that information which the government wants, okay, to deliver to us. So GPS is of USA. In 1973 it was being used for the military purposes, and in the 1980s they started to use it for the civilian purposes. So it is a constellation of 33 satellites. And why they have more number of satellites? Because they are covering all of the earth. Okay, this GLONASS is of Russia and they started it in 1982. And this constellation has 26 satellites, and out of these 26, 24 are in orbit. Okay, and this Galileo, it is of Europe. This is a constellation of 30 satellites, out of which 22 are working. So this information is not important that how many satellites they are having. Okay, only the relevant information for the exam point of view is the Galileo, GLONASS, GPS और ये किस country को belong करते हैं. And the fourth one is BeiDou. BeiDou is of China. And on 23rd June 2020, China launched its final satellite of the BeiDou constellation. And it will have 35 satellites, all are in the orbit. Okay. Now there is one more thing. There is one more concept. Please write. We have the Kessler syndrome. Do you have any idea of the Kessler syndrome? Okay. Yes, Galileo for. Yes, Nikhil?
Is it the radiation syndrome in the space, sir? The Caspian syndrome?
No, Nikhil, it is related to the satellites. Okay, the satellites that we are having in the low Earth orbit. So basically, the low Earth orbit, it is crowded by these satellites. Okay, and the satellites, they have a shelf life, and after some time, we have to either replace them or they are just like the debris. Okay, the old gadgets rotating around the Earth. So there is a, we can say that a debris of satellites in the low Earth orbit. Okay, there is huge number of satellites, and because of this crowding, it is getting difficult to insert more satellites in the orbit. Okay, so the Kessler syndrome, it refers to the effect if there will be any collision in these satellites in this debris. Okay, then the collision, there will be a chain reaction of collision between all of this debris, and the functional satellites, they will be caught in this Kessler syndrome. Okay, they will also get damaged in the process because there is crowding of satellites in the low Earth orbits. There are so many satellites, functional as well and non-functional as well. And if there is any collision between the two, okay, anyhow, so that there will be a cascading effect. That effect will increase. There will be a chain reaction of collision, and in that reaction, even the working satellites, okay, they will be caught in that chain reaction and they will be destroyed. Kessler syndrome समझ में आया? एक बार कोलिजन वहां पे स्टार्ट हुआ सैटेलाइट्स का, फिर वो रुकने वाला नहीं है, ऐसा प्रपोजल था. There was a person known as Kessler and he proposed this. So this is known as the Kessler syndrome. Okay. We have to launch separate missions to remove the space debris. or by some kind of controlled collision or putting the debris in the Earth's orbit so that there will be controlled burning of all this debris. So these are some of the solutions that the scientists have thought of. Okay, they have planned it. They will push the old debris, old satellites into the Earth's orbit. Okay, into the Earth's atmosphere, and in that process, when they will enter the Earth atmosphere, they will be burned down. So this is one way to finish the debris, and the other way is to buy some spacecraft to catch all this debris and bring it down to the Earth. So there are two ways. Then we have this Gagan, which is the GPS aided geo augmented navigation satellite. Okay, so this Gagan, it will be developed in collaboration with the Airport Authority of India, and obviously ISRO is there. Okay, so the equipments that are related to the Gagan, they will be on board the GSAT 8 and GSAT 10 satellite. The geostationary satellite 8, these are the name of some of the geostationary satellites under the GSAT series. Okay, so these satellites, they will carry the payloads related to the Gagan. Okay, so it will be used in the navigation systems. So Gagan is the first satellite based augmented system in the world. Okay, and which has been certified for approach with vertical guidance operating in the equatorial ionosphere region. I do not know what it says. Apart from the civil aviation, Gagan also provides the benefit to other sectors like railways, transportation, highways, and telecom industry. Okay, so the railways, they will be using the Gagan satellite. Okay, it will be used in the transportation sector to monitor the highways and as well in the telecom industry. So this is all about the Gagan. And this is the Amazonia 1 satellite. Okay, now the ISRO is earning money by launching the satellites of other nations. So this is the satellite of Brazil. So ISRO is launching this Brazilian satellite and it is named at Amazonia 1, and it will be launched by using a polar satellite launch vehicle. Okay, and images from this satellite, it will help in observing and monitoring the Amazon rainforest, the deforestation process that is happening in the Amazon region. Okay, is it clear? So now ISRO is earning money by launching the satellites of other nations. And even if the other nation like the European Space Agency, they use the services of our PSLV because PSLV is cheaper. क्योंकि उनको सस्ता पड़ता है, PSLV पे ऑन बोर्ड करते हैं स्मॉलर सैटेलाइट्स को और इंडिया उनको लॉन्च करे. PSLV का सक्सेस रेट भी ज्यादा है, PSLV सस्ता भी है. So even the European Space Agency, instead of using their own launch vehicles, they are using the PSLV. Okay, I think some of the people have disconnected and it is already 7:05. So we will resume from here tomorrow. Okay, and we will complete the space technology part. Okay guys, so this is all from my side. Thank you and see you tomorrow.